Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, happy Tuesday to you, eights. So, hey, first of all, we're still floating in our family and out in Australia over Brighton's opportunity to play in the grand final and actually come back and win it. Their team was down like 12 points at halftime, 2 tries. And their coach gave them a little speech at halftime. It's kind of cool. And he said to them, he said, I want you to leave every ounce of energy that you've got on the field in the second half. And it was inspiring to them. And they played their hearts out and held the other team to no points in the second half and came back to win. So anyway, so you can see why we're still floating. So, and I got a chance to talk to Brayton, so it was really cool getting a chance to talk to him and congratulate him. So, by the way, in the photo that you see, Brayton is on the left side. He's the second person. He's got his hand up in the air. He's got his really crazy little rugby hat that doesn't do anything, well, maybe minimal protection. It's one of the reasons as a grandpa I'm going, could you just play baseball, which he's starting now? Could you just play baseball and not rugby? But he loves rugby, and his dad loves him to play rugby, and his dad played rugby. And anyway, so I'll live with it, but I'm glad he's playing baseball now. So anyway, let's get going. I hear good reports from Mr. Gilbert about how well you're doing with the do-nows and just how well you're managing, paying attention during the videos and all of that. Now, he and I talk every day, like he's probably told you, and we have hatched the idea of the activities in the back of the room, which we'll inaugurate today. So we'll start that today, and more about that in a little bit. So anyway, so keep doing what you're doing with your journals every day. So write in your journals. I hear good reports that you're doing that. You're putting your homework in your lesson planner. So I hear you're doing that. Today, if you take out a red pen, you're going to use a red pen, and if you take out a highlighter. So while I'm slowing down what I'm saying, you're taking out a red pen, please, and a highlighter. And if you'll have all that at the ready. And if you'd have your book open to page 4, we're going to do some work in our book and use it. I'll be telling you about homework in a little bit. So textbooks every day, so please bring it with you every day. So anyway, we'll get to that in a little bit. Hey, just a reminder about the extra credit opportunities that are on the table. And because of the haze we've got in the sky, have you seen it? Is it smoke from the fires in California? Yeah, it is. And maybe even from Oregon and Washington. I don't know if the jet stream is sending them all. It's the jet stream that's sending the haze over us. And it's high level smoke. But the problem is now, when we go out in the evening to look up at the planet pairs, so first in the evening, Jupiter and Saturn, the Galilean moons of Jupiter, and when you go to look, it's harder to see. It's hard enough to see here in Phoenix because of the light pollution, all the light that's shooting up into the night sky from all of the different light sources in Phoenix. We're a big city, a lot of light going up into the air, and it drowns out the night sky. So, and it's one of the reasons you probably saw that. Just to double check the number, I think it was like if we were in a perfectly dark area with no light pollution around, we could see anywhere from 2,000 to 3,000 stars. Even though in the Milky Way galaxy there are billions, and in the other galaxies there are billions as well. But we could see a few thousand. But here in Phoenix, it's just too much light pollution, but we can see a number of stars and a number of other things. So again, you're looking for the evening planet pair, and then there's the early morning planet pair, 5:30 or so. So, and you're looking for it, and what would that be? That's Venus, so bright because of high albedo reflectivity, the sun reflecting off its atmosphere. Second brightest object in the night sky after the moon. And then Mars is up overhead to the west, orangish because of iron in the soil, oxygen combined with the iron oxide, and then there had to be water too to make the rusty soil. So don't forget stellarium as well. All of these opportunities are 10 pointers, get a parent signature turned into the basket. So get all that done. Now with stellarium, remember you've got to spend 10 to 15 minutes on it, customizing it for you, looking at it, what is in the night sky, and all of that. So, or use a phone app. If you're going to use the phone app, that I mentioned yesterday, I don't care. Spend time with it though, 10 to 15 minutes. Okay? So, and that would work as well. That would be fine. Okay. If you take out your verse sheet, I'll slow things down while you're taking out your Bible verse sheet. This week, on the test on Friday, you're not going to have to write Genesis 1:26. But I am going to ask you for John 1 through 3. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things came into being by Him, and without Him, nothing came into being that has come into being, or through Him, if you use that version. I don't care. I'm giving credit for both. So you write John 1 to 3. It'll only be worth 2 points this time. Then you're going to write Psalm 139, 13 to 14. I already had you highlighted, I think. And it goes right along with the cells that we're studying and some early genetics. And what's the idea behind it? Well, first, let me quote it. For you formed my inward parts. You knitted me together in my mother's womb. I praise you because I am fearfully, awesomely, and wonderfully made. Wonderful are your works, that would be me, and my soul knows it very well. David wrote this. And David's saying, I got it. Lord, I get it. You designed me. It's amazing. You designed my human body. You gave me my personality, my soul and spirit. You designed me. Now, he didn't know about DNA. So above Psalm 139, 13 and 14, I want you to write, God designed me, emphasizing the D. God designed me using my DNA. God designed me using my DNA. Don't say it out loud, but say it in your head. What's the meaning to Psalm 139? God designed me using my DNA. So, and as we study DNA this year in genetics, you're going to go, holy cow, it is so complex. You got that right. In fact, it's like the number one primo argument that there has to be a God. There's a scientist who's a Christian who's written a book about DNA that's that thick. I don't know, 700-800 pages. And he uses it as an incredibly strong argument that there had to be a God who designed DNA because there's no way it formed by itself. It is so complicated. Anyway, more about that later. So DNA, you got to love it. So anyway, also I will have the scientific method on this week's Friday test. I've got a story for you about a scientific method problem. Here it is. And I want you to figure out what part of my story matches each part of the scientific method. Here it is. The question is, which of a bunch of liquids that you test is the heaviest? or the most dense. And the reason one liquid would be heavier than another is more atoms are packed into the same space, are concentrated into the same space. More atoms. Well, each atom weighs something, so the more atoms you have, the more weight you've got. That's density, okay? Just atomic packing, how tight the atoms are packed. So anyway, here's the way it works. Here's the way you do this experiment. Same container, same amount of liquid each time in the container, different liquids, but in the same container, made out of the same material because it's the same container. Same balance. You're obviously weighing it in the same way. And then you take that liquid out and pour it back into its original container, clean it out, and then put another liquid in. Same amount, weigh it, same balance, write each one down. So you're writing down the weights, okay? And you do this with a whole bunch of different liquids. By the way, you make a scientific guess in the beginning about which liquid you think might be more dense. By the way, what do you think it might be? Say it to your neighbor. Go ahead. What liquid do you think would be the most dense? I don't know if this exactly is the densest, but it's one of them, but I think it might be the densest. What is it? Its chemical symbol is Hg on the periodic table of elements. What is that? Mercury. It's that silvery liquid that we put in thermometers. Mercury. Okay? So, steps of the scientific method. What step would it be where you ask the question, which of a bunch of liquids, different liquids, is the densest? That would be the problem, the question. Okay? And then you make an educated guess what it might be. That's your hypothesis. There's a whole bunch of differences. You've got a whole bunch of differences that you've got to make sure you keep the same except for one. So what are those differences called? Variables. What is the step called where you keep all the differences the same? Same balance. So you weigh it the same way. Same amount of liquid, same container. What step of the scientific method? Controlled variables, right? This is the kind of thing I'm going to ask on Friday. I'm going to tell you a little story, and you've got to identify the steps of the scientific method. Okay? And then show me on your fingers how many variables is it scientifically okay to not control or keep the same. Show the number. Mr. Gilbert's looking. How many variables not controlled? One. By the way, that's called the independent variable. But I don't care that you know that. Okay? Then you wrote down all the weights in kind of a diary, in a journal, or like a diary. What step? Say it out loud now. Yep. That is the data step. Diary, data. The data step. And then from the data, you get answers. Conclusions. Okay? So steps of the scientific method. Hey, changing the subject just for a minute. Were you aware of this in the news? Science in the news. August 20th. We had a near miss. What? Near miss. We had an asteroid, a big rock chunk, just miss Earth. Really? Yeah. Just missed. What do you mean just missed? Well, by about 1,800 miles. Oh, Mr. C. That is the distance from approximately Chicago to Los Angeles. I know, but in astronomical distances, that's close. That's the closest asteroid that we've ever noticed and written down coming to the Earth. Closest that we know about. Okay? How big was it? It was about the size of a truck, like an F-150 or something. Okay? Ooh. Did any of it hit the Earth? Meteorite? No. As far as we knew, no. I'll try it again. Just said it Mr. C. It missed us. By the way, though, it did get pulled in by a gravity and changed 45 degrees in its path as it bypassed the Earth. Here was my hypothetical. If it had hit the Earth's atmosphere, what would have happened? Would there have been any left over to hit the Earth? Probably not. It probably would have been a bright fireball, kind of like I saw in 1970 at that camp I was working at. It probably would have been a fireball meteor. So, by the way, in 2003, there was an asteroid about 65 feet across that actually plowed into the atmosphere above Russia, a lot bigger than this one that just came by. What happened then? A number of pieces, little bits, hit the Earth, mostly burned up though, but there was an explosion relatively close to cities that blew out thousands and thousands of windows. And I think there were injuries due to like blowing glass, flying everywhere. But still mostly burned up. So anyway, interesting stuff. Hey, how fast was it going? 27,600 miles an hour. Okay, closest ever recorded. Kind of interesting. So yeah, very interesting. So I just thought I'd throw that out there. No charge. I'm not going to charge you for it. I should charge you, but I'm not going to. Okay, I want to go over your answers on pages 6 and 7. But first, let's do this. Could we read this together? This is page 4. Would you look at page 4 and I'll do a dramatic reading? Will it really be that dramatic? Well, no, but the best I could do. Here it is. So you've got My Planet Diary right there, and here's what it says. Life at First Sight. Anton van Leeuwenhoek, I think that's how his name was produced. He was Dutch. What gave you the first clue, Mr. C? Van. Anton van Leeuwenhoek was the first researcher to ever see bacteria under a microscope. He made his own microscope. Because on this page, coming up, you can see his microscope. In his journal, he described how he felt after discovering this new and unfamiliar form of life. Here's what he said. For me, no more pleasant sight has met my eye than this of so many thousand of living creatures in one small drop of water. So he was seeing bacteria. So, and up here, would you write your hypothesis in up here? See that right there? Page 4. Look what it says. Why do you think van Leeuwenhoek was so excited about what he saw? Write down why you think he was so excited. So you're writing down just a hypothesis. Really quick, do it fast. Please, when I ask you to write in your book, do it real fast. I like the way they have these little, write down your own hypotheses. So, well, who knows? It could be a bunch of things why he was excited. He had never seen anything like it before himself. Okay? And they were moving. So he was like, these might be alive. Thousands of them. And the book says he saw living things smaller than anyone knew existed. That could have been the reason too. So anyway, cool stuff, really cool stuff. So, okay. So, gotta hurry because we've got our science activities to do today. All right. So, over on this page, on page 5, right here, I want you to have a look what it says, and it shows a cell, and it right here talks about cells, and it says that cells do these functions for an organism. And it says right there what they do. I'm going to ask you these on Friday. So what do cells do? What function do they, do they provide for the cell? Well, it's LGR. So here's what it says. They their function is to do the processes that keep an organism living, help them grow, and help them reproduce. LGR. help keep them alive, help them grow, help them reproduce. So you're writing those in. In fact, you might stick those on LS1. Help living things to live, stay alive, to grow, and to reproduce. Okay? So that's what they do. And then up here, it shows what goes into a cell and what comes out. See if you can finish that. What goes in, what goes out. Do you see up there where it says single cell? What are the things that go into the cell? Those would be the red arrows that are going in to the picture of a cell. So what goes into the cell, what does it need? O2 in. So oxygen going in, O2 in, into the cell. What else needs to go in that the cell needs? Needs food. It needs water. So all of those things are going in to the cell. What's coming out? I have to do this. I have to. So O2 in, do it right. O2 in, CO2 out, O2 in, CO2 out. That's carbon dioxide, right? That's what animals and humans are breathing in. Oxygen, O2, CO2, carbon dioxide out. So you're showing coming out of the cell, it's already there actually, carbon dioxide. And what else is coming out of the cell? Leftover water. It has excess water. Wastes. And then it shows the things going in. Things going in, things going out. Are we going to have to know that for the test? Well, sure. Probably two each. Two things that go in, two things that come out of cells. Okay? And again, what do cells do for organisms, for living things? They help them live, LGR, live, grow, and reproduce. Okay? Okay, we've got to answer some questions over here on page 6 and 7, and I have to hustle. Woo! Do I have to hustle? Okay? So, you had down the different kinds of microscopes, and here's what they ask. What was important about Hooke's work using his microscope? There's Robert Hooke's microscope. 1665, folks. Good grief. How many years ago was that? About 350 years ago. No microscopes up till then. It's not very long in history that they've been around, comparatively speaking. You know, when you think about it. When history is, 5,000-6,000 years. Okay, so he was the first to see the leftovers of cells. And he named them. What did he call them? Cells. Robert Hooke named cells. And then here's Van Leeuwenhoek's microscope, right there. And what did he observe? He observed living things that were moving around and that were smaller than the eye could see. So, pretty cool. And then over here, in where it mentions cell theory, it says here, in which part of the cell theory and it's Rudolf Virchow, he wrote down some things about what he thought about cells, kind of hypotheses. He said all cells come from other cells because they reproduce. So that's what he said. So now, if you didn't write those in, use your red pen and write them in. Use your red pen, write them in. Okay? Now, we have got to get rolling so I can get you going on this activity. So here's the way it's going to work. Mr. Gilbert's going to give you a class number, just down the class list. You're going to get a number that's an odd number or even number. Odd numbers you're getting up and you're working today in the back of the room. You're only going to answer 2 questions in your journal. In the A section, the B section, the C section, the D section, or what I call the WC section, the wild card section, okay, which is scattered around the room. Okay? You're going to answer 2 questions. You're going to have 8 minutes. You can't talk to anybody. You can't get help from anybody ever on the answers. That's not right. Can't do it. So be honest about it. Okay? So you've got to respect the opportunity. You can't mess around. Okay? So only 3 people in each of the sections. So only 3 people max in the A section, the B section, the C section, the D section, or the WC section. Okay? Don't touch anything. Just write in your journal. Look, but don't touch. You can look, but don't touch. Okay? Now do it right. Follow the rules, because I want you to keep getting to do this every week. You want to keep being able to do this, don't you? Well, I hope so, because you get up and be active and not just sit at your table. And that's the reason that I've wanted you to be able to do this. I've thought about this since school started. How do I get you up some days and allow you to be active? So anyway, I've wanted to do this. Okay, so Mr. Gilbert's going to give you a number. Then he's going to get you folks that have odd numbers, he's going to get you working. Okay, he's going to set the timer for 8 minutes. Even numbered people, you're going to work on your homework. You're going to make sure your book got filled out if it didn't. You're going to read and highlight in your lesson summary, number 1. You're going to look at your book and you're going to highlight things from your book on your lesson summary. Okay, and then you're going to review the scientific method and verses, those of you who are at your seat. So use the time to review. Okay, and I'm going to turn it over to Mr. Gilbert now. Thank you, Mr. Gilbert.